So today we're going to start learning about simple machines. I'm not sure if you learned about simple machines in previous years. If you did, it was probably 5th grade. So hopefully you know a little bit about simple machines, but they are, very easy to learn about. So the first thing I want to do is talk about just what a machine is. So we all have an idea of what a machine is, but the actual definition of a machine is a tool that helps us do work. So that's why we have machines, is they help us. And they can help us in 2 different ways. So they can change the amount of force on an object, meaning that if I need to use a tool or a machine to help me push something really hard or pull something really hard, that's a machine's job, is to help me pull or push harder than I could just using my hands. The second job of a machine is to change the direction of the force. So maybe I can only, push forward on a certain object based on how it's built, and a certain machine could help me change the direction of the force so I can, pull it towards me. So what is a simple machine? A simple machine is a machine that only has a few moving parts, or it can have no moving parts. And their job is just to make things easier. So you can see in these pictures, so for example, this simple piece of wood, that is a type of a simple machine. It's considered an inclined plane, which we're going to talk about all the different types of simple machines in a minute. But an inclined plane basically is a ramp. So she's using it as a ramp. So this is making her job easier. So rather than having to go up a flight of stairs to move the box from down here all the way to wherever she's pushing it, she can use this simple machine to help her make the job easier, because now all she has to do is push it up the flight of stairs. Over here is a lever, which is just a hammer. So a hammer can be used as a lever. And you can see it's actually this part of the hammer. So not the part that you pound with in this example, but the other part. So in this example, we're using the machine to change the direction of the force. So we're actually taking that little piece, putting the nail in between it, so that way we can remove the nail by applying less force than we would have to if we were trying to do it with our bare hands. Another simple machine is a pulley. So a pulley looks something like this. You can see it's going to help the flag lower and raise just by pulling on the rope. A wedge here. A wedge is used to split things. So in this case, this axe is being used to split the wood. Again, this tool makes it a lot easier than if you were trying to do it without any tool. And lastly, a screw. So a screw helps keep things together. Next part, force. So force, whenever we're talking about force, we can either talk about a push or a pull. So you can push a bookshelf to move it. One of the things that I want to talk about is, again, machines, or simple machines, try to make the job easier. So to move a bookshelf, if it has a lot of books on it, it might be pretty hard to push. But if I use some sort of simple machine to help me, it would make the job easier and I wouldn't have to apply as much force. Energy is defined as the ability to do work. So it says the example is you have to have energy to run the mile. The whole point of talking about energy is in order for us to use simple machines don't typically run on their own. We still have to apply force, and in order to do that, we have to use energy. So the definition of work is the result of force moving an object. So the example is picking up something heavy is hard work. So again, you have more work with the more force that you have to put forth. Gravity. Gravity is the force that constantly pulls objects towards the earth. So the whole reason, for example, that a bookshelf is hard to move is because there's always gravity pushing things down, and that's how we get weight. So that bookcase would not be that heavy if we didn't have gravity, because gravity is pushing it down, which causes it to be heavy. Okay, so finally getting to what the simple machines are. So these are the same simple machines we talked about in the previous slide. We have 6 simple machines, and again, they have few or no moving parts. So that's the lever, inclined plane, wedge, screw, wheel and axle, and pulley. So the first simple machine that we are going to talk about in this video is a lever. So a lever is made of a board or a bar, and it's set on top of a fulcrum, and it's used to lift weights. So let me explain. The easiest example for me to talk about is a lever. A seesaw. So a seesaw is a lever because, again, it's made of a board, and it's used to lift weights. So you can see just by pushing down, he's lifting her up. And when she pushes her force down, he's going to lift up. You probably don't know this word fulcrum, but on a lever, so a fulcrum is part of a lever, and it's the part that does not move. So on the seesaw right here, this piece is the fulcrum because this piece is not moving. Okay. Another example of a lever would be this crowbar. So again, we could use this bar to help us apply force and either lift weight or push something apart. A baseball bat, again, it's just a board or a bar, so it's just basically a stick in this case. And it's used to apply force, most cases, to maybe a baseball ball. A baseball. And then finally a rake. So a rake is a lever because, again, it's made of just a board, and it helps us do a simple job. So whenever you're looking at levers, your job is to look for something that's just like a straight board or a straight bar. Also notice, again, that you need to know the word fulcrum, so I would highly suggest putting a star next to that because that's probably one of the harder words in this section. Okay, the next one that we're going to talk about is an inclined plane. So an inclined plane basically is a ramp. It's a slanted surface that helps make lifting easier. So as we saw earlier, the girl was lifting a box by using a ramp. In this case, they're using this ramp to lift a boat. So it's any sort of ramp. That's what an inclined plane is. A few other examples, or real-life examples, are stairs. So again, the job of an inclined plane is to help us get from one place, like a lower place, to a higher place, or move objects from a lower place to a higher place. So if we didn't have these stairs, it would be really hard to get from the first floor to the second floor all the time. So it helps the job of getting from one floor to another be a lot easier. This one I like to talk about, the bathtub. So a bathtub, you don't think that it's slanted, but it is. It looks flat. If you go home tonight and look at your bathtub, it looks flat, but the way it is installed, it's installed at a slant, and the purpose of that is if it was not slanted, then any water that got right here would stay right here. Okay, so since it is slanted, this part is higher up. Again, you don't really notice it, but it's higher up, so that way when the water gets here, it's going to start flowing back towards the drain. So we don't want bathtubs to be completely flat, or we would always have standing water sitting in our bathtub. And this is just a plain old ramp, just to show you that inclined planes are just ramps. Next one is a wedge. A wedge is when you have two inclined planes together, and they are used to either raise an object or split an object. So most of the time I think about they split an object. So knives split objects. This is an axe. It split objects like wood. But one of the things that people typically forget is that a wedge is actually two inclined planes. So the easiest way to explain that is if you look at the head of this axe. This axe is slanted on this side as well as the other, so that is our two inclined planes on the axe. So please make sure when you're writing the definition of a wedge to include that it has two inclined planes and that it's used to split things. Another cool example of a wedge is a zipper. So a zipper splits things. And then obviously here we have our knives again. The next one is a screw. So a screw is an inclined plane wrapped around a pole or a shaft that is used to hold materials together or drill holes. So basically a screw, there's not a ton of examples of screws. A screw typically is a screw. And the job of a screw is to hold things together. You can also see it says a screw is an inclined plane wrapped around a shaft or cylinder. So you also need to include in your definition that a screw is a type of inclined plane, but it's wrapped around. So this part right here that you can see wrapping around would be considered an inclined plane, but it's wrapped around a cylinder, which makes it a screw. You can see it also says the inclined plane allows the screw to move itself when rotated. The next one, wheel and axle. So a wheel and axle is a wheel that turns on a post to help move things quickly and easily. So wheel and axles are easy to spot because you're always going to see something in a circular shape, except for screwdrivers. So screwdrivers are considered wheel and axles because we actually turn them in like a wheel type shape. So we turn them in circles like we do with the wheel, which makes it a wheel and axle. But for your examples, most of them do have a circular shape or a wheel shape. So a doorknob that looks like this is considered a wheel and axle because, again, you have to turn it in a round motion. If you look at my doorknob right now, my doorknob is not a wheel and axle. You can see that it actually has a lever to open and close it. Steering wheel and screwdriver are also examples, so make sure you use those in your notes. These are just real life pictures of wheel and axles. The next one is pulley. So a pulley is made of rope and string wound around a reel to change the direction of a force. So with the word pulley or the simple machine pulley, I always think of pull. So in order to use the simple machine pulley, you have to pull on something. So the easiest one to talk about is the flagpole. In order to raise or lower the flag, we have to pull on a rope. So it is a pulley. You can see also different examples. We have a clothesline, so we can move the clothesline by pulling, fishing reel, and then this is a crane. These are just some real life examples. Notice it says a pulley means a rope or chain or belt around the groove to make it do its work. Next, I want to talk about compound machines. So we said simple machines have few or no moving parts. A compound machine has two or more simple machines working together. So it's more complex. So a bike is an example of this because you can see it has wheels, it has a lever, lots of different simple machines together, and a car, you can imagine, has a ton of simple machines. So a simple machine has only a few or no moving parts, whereas a compound machine has two or more simple machines in it. Last one is simple machines can be put together in different ways to make complex machinery. So basically, simple machines make compound machines and complex machines. Okay, so it all starts with simple machines. Any machine that you see all starts with simple machines. Okay, that's it for this video. You can check the board to see what to do next.